Hello students, you are welcome to the YouTube channel of Sri Saraswati Bhuvan Education Society, Chhatrapati Sambhajinagar. Today we are going to learn about the chapter number 5. The name of chapter is the Inside the Atom. So actually in the previous standard you have learned about the smallest particles of most of the substances, that you know that they are the atoms and the molecules. So when we see in the nature, the molecules of few substances, they contain only one atom, but the molecules, they are formed by the combination of various atoms. That it means two or more atoms, they chemically combine together or they come together and they forms the molecule of any compound. So from this we can conclude that the smallest particle of an element which takes part in a chemical reaction is called as an atom. So you will be thinking that the atom is a new concept, but remember, the concept of atom is more than 2500 year old. So it was forgotten in a course of time, but there were so many scientists, on the basis of various experiments, they explained the nature of atom as well as the internal structure of atom. So here in the present chapter, firstly we will study how is the internal structure of an atom, and then after we will see the important facts related to the atoms. Remember, as we know that the India is a country of knowledge, and I would like to share one name, that is Maharshi Kanad. He was the Indian philosopher in the 6th century BC. Maharshi Kanad, he stated that there is a limit to divide a matter into a smaller particles, and he told that the indivisible particle that constitute the matter, and he named that particle as the Parmanu. So the meaning of Parmanu is the smallest particle. That it means he told that the atom or Parmanu is existing in nature. He again told that the atom is, or the Parmanu is, indestructible. That it means it cannot get destructed by any means. Then I would like to share one name, that is the Greek philosopher. His name was the Democritus. He was existing in the 5th century BC. He stated that the matter, it is made up of the smallest particles, and he named that particles as the atmos. Actually the atoms was named as atmos earlier on, and then after the concept of atom, it was got in existence. So that it means that the atom is not a new concept. It was quite studied by the various philosophers, various scientists, so many decades and thousands of years ago. Now when we say the atom, we have to study the internal structure of atom with the help of so many theories which were put forth by the various scientists. So firstly we will see the Dalton's atomic theory. Dalton was a British scientist, and his name was the John Dalton. He put forth his celebrated atomic theory in the year 1803, and remember, according to his theory, the matter is made up of the atom, and it is indivisible and the indestructible. So the all atoms of element are alike, while the different element have the different types of atoms, and the masses of the atom of different element is also different, he told in his theory. Remember, Dalton put forth the atomic model, and in his model he said that the atom is a rigid, solid, and it is a spherical structure. So on the basis of his explanation, the atom was a rigid structure. But remember, later on Sir J.J. Thomson, he was a scientist. He demonstrated experimentally that the atom is not a rigid structure in which all the mass is uniformly separated or distributed in it. But he told that with the help of some experiment, that the atom, it possesses the negatively charged particles in it, and the mass of that negatively charged particle is 1800 times less than that of mass of hydrogen. That it means very less mass having something is there in the atom, and he named that as an electron. Remember, when we see the substances or the elements, generally the atoms of elements are electrically neutral one. So the reason behind that is the obviously the positively charged mass and negatively charged mass, they must be neutralizing each other. So the question arises in our mind that while the atom, if it possesses some charges like the positive charge or the negative charge, then when those atoms they chemically combine together and they forms any substance or the molecule of any substance, that molecule is electrically neutral. So how it is possible that if the atom is possessing some charges on it or charge particles in it, but the molecule which is going to form with the help of atom is chemically neutral? So the plum pudding model, which was put forth by Sir J.J. Thomson, gives us the answer why the elements or the molecules which are going to form with the help of the chemical combination of atom is electrically neutral. Remember, this is the plum pudding model which was given by Sir J.J. Thomson. So what this structure shows us, remember, you can see the red part in this structure. The red part is the positively distributed charge in it. That it means all the mass of atom, it contains the positively charged particles, and the negatively charged electrons, they are embedded in the that positively charged mass. So this model was named as a plum pudding. You must be seeing the next diagram here, that is of watermelon. Remember, watermelon, if we cut the watermelon into slice, you will see that the red color part of watermelon, it is distributed evenly in the inside structure of watermelon, and the seeds, they are embedded somewhere. So similar to that, Thomson said that the plum pudding model of atom is similar to the watermelon structure, that it means evenly spread positively charged particles and the negatively charged electrons embedded in it. So this was the Thomson's atomic theory. So now we are coming to the Rutherford's nuclear model of an atom. Remember, Rutherford, he studied the inside of atom by his celebrated scattering experiment, and he put forth the nuclear model of an atom in the year 1911. So what was the experiment of Rutherford, which is known as the scattering experiment? So you can see here the diagram of scattering experiment. In this we can see that actually the lead block is used there for shielding, and he used the alpha particles. Now remember, alpha particles are positively charged particles, and he took a gold foil of thickness of 10 raised to the power minus 4 millimeter. That it means it is very thin, and he bombarded the positively charged alpha particles which were emitted by the radioactive substances and on the gold foil. So I would like to share one thing with you, that the alpha particles are such particles, that means they are energized particles, and they can get penetrated almost through everything. So when he bombarded that alpha particles on the gold foil, he was shocked. Actually, his conclusion was that if Thomson says that if the inside of atom is evenly spread with the positively charged particles, if alpha particles are positively charged, inside the atom is positively charged, when those positive charges will come together, surely the alpha particles will get reflected back. So when he carried out the experiment of scattering, he saw that very few of alpha particles, they were get turned back. Most of them, they get deviated through a large angle, most of them get deviated through the small angle, and very few of them, they get turned back. If we consider the number of alpha particles, if we consider the sent alpha particles on the gold foil were 20,000, only one of them were get bounced back or got returned. That it means very few space in the atom is there which possess the positive charge, and on the basis of the observation of his experiment, he proposed the model of an atom. Now the conclusions of the Rutherford's atomic theory was that, or the scattering experiment was that, the atom, it consists very tiny particle or a tiny mass which contains the positive charge. So we can say that the nucleus is the space where the protons are present which are positively charged, and he told that there is empty space in the atom, and the negatively charged electrons, they must be revolving around the atom in a circular manner or in the orbit. So this was the atomic theory which was put forth by the Rutherford. But remember, according to a law of physics, when any object, it revolves around any another object in a circular manner, or if it is going to orbit it, when it orbit it, the energy get decreased, and surely that object, if it is the negatively charged and proton is positively charged, surely it will get fall down. So this model which was put forth by Rutherford, it was not accepted, and then after the Bohr stable atomic model, it came in the existence in the year 1913. So Sir Neil Bohr was the Danish scientist, and he explained the stability of atom by putting forth the stable orbit atomic model. So the postulates of Bohr's atomic theory was the electrons which revolves around the atomic nucleus lie in the concentric circular orbits at a certain distance from the nucleus. That it means the centrally situated nucleus will be there, and the concentric circles of the orbits will be there, in which the electrons, they will move there. So when we say that the energy of electron will be constant in a particular orbit, that it means if an electron is present in a specific orbit, it should possess some amount of energy which is required to stay in that orbit. If that electron wants to leave that orbit and he wants to go in the higher energy level orbit, then that electron has to gain or absorb some sort of energy that will be equal to the energy of the next orbit. So one can conclude that when the electron jumps from the inner orbit to the outer orbit, inner means lower energy level orbit to the higher energy level orbit. So he absorbs energy which is equal to the difference of energy level, and when it jumps from the outer orbit to the inner orbit, surely it emits some sort of energy which is equal to the difference between the both orbit. Okay, so we conclude that the electron, they stays in the orbit, they revolves or they orbits around the nucleus, and they are present in the extra nuclear part of the atom. So I am going to show you one experiment, and I will explain it later on. Please watch the experiment. So in this particular experiment, I took sodium chloride, which is known as common salt, which we eat in our day-to-day life. So when I sprinkled that sodium chloride on a gas burner, you must have watched that the yellow colored flame. So why we can see the yellow colored flame when a salt is sprinkled on a flame? So remember, the electrons which are present in the atom of sodium, if they goes to the higher energy level due to the energy absorbed by the flame, and they cannot stay there for a longer duration of time due to the instability, they will again come to their original orbit. But remember, while coming to original orbit, they have to emit the energy which was absorbed by them from the flame. So they emit the energy in a form of light, and that light is equal to the intensity of yellow colored light. So remember, we use the sodium vapor lights on street, they also gives us a yellow color. If we take the sodium chloride solution and we burn it on any ignited flame, it will surely give the yellow colored flame. So this was the answer why we can see the yellow colored flame of sodium chloride salt when it was burnt on the flame. Thank you. The next part of this chapter, we will study it in the next video. Thank you very much for watching.